Okay, I'm going to try to make a quick video here for this measurement activity that we were given at the end of class, how to measure properly. I'm just going to annotate this paragraph because it's got a lot of stuff to read. Digits represent a certain value based on their place. Okay, this is kind of grade school stuff. Red in columns, ones, blah, 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 blah. The numbers to the right have a place value. Okay, so I already kind of know this. So ones, tens, hundreds, thousands. Okay, and these ones are the same, but they got the THS on there, so this is a big word, thousandths, and 10,000ths. That's just kind of a number line there, helping us out. Let me scroll down a little bit here, and I'll erase my stuff. Okay. Good laboratory experiments require precise measurements. Okay, that sounds important. Precision of the measuring tool depends upon the scale of the tool. Oh. Teaspoon is more precise than a measuring cup because they measure a smaller amount. Precision in the instrument, okay, this sounds important, depends upon the smallest scale division of the instrument. The smaller the decimal place, the more precise the tool is. Metric ruler that has millimeter marks is more precise than one that doesn't. And this is kind of like what we did with our string people experiment. So now I got to fill in this blank down here at the bottom. Two examples of proper measurements showing how the last digit is always doubtful or uncertain. Okay, more, I don't know where my examples is there. But measurements tools with different scales of measurements. I'm going to say truck scale, which is like what you see along the highway. That's used for measuring the weight of trucks. And then I'm going to say bathroom scale, or more precise, because that kind of helps you out. Rulers works, graduated cylinders works, but we might have to have kind of some pictures that go along with that. So that's kind of a nice, easy example that I think that most people can identify with here. Let me get a clear page here, and I'll go on to the next page. Again, this was all kind of easy here on this first page. Okay. Doubtful digit is a best guess estimate of the 10th fraction of the smallest scale. Oh, okay, that's confusing. What does that mean? This ruler measures to the ones place. Okay, so that was here on our number line. That's the number that we're sure of. Okay, so we're sure of 1, 2, 3, 4, 5, 6, and 7. And so I know for sure that this number is in between 6 and 7. So it is definitely in there. So we talked about this with some groups. We want to estimate one more place value than that of which we're sure of. We are sure of the ones place, so we're going to estimate to the tenths place. So for this one, I can either say that it's 6.0, 7.0, or 6.5. And some of you are maybe thinking that I could say that it's 6.4 or 6.3 because it looks like a little less than half. And we're going to try to avoid guesses like that because if you can see that much variation, you're probably not using the right tool. So now let's take a look at the different ruler down here at the bottom. Okay, now this one, the scale, these little lines are worth 1. So this is in between 6.3 and 6.4. So I know that this is definitely 6.3, and everyone in the world would guess 6.3 something, and I have to estimate one more place value past that. And again, my options are 6.30, 6.35, or 6.40, because that's okay, and we're okay there with whatever, because we're always saying that this last value is just a guess. And when the scales that we use in the labs, those last numbers kind of fluctuate, it's for that same reason, is because that last number is a guess. So 6.35 is a good measurement for this ruler for exactly what I just talked about, is because it is measuring one more place value than that which is given. Okay. So now this is applying it here. It takes a little bit of thought. We have to figure out what place value each line is going to. These lines are counting by the hundredths place. So again, if we had our hundredths place, okay, and then here's this. This number we're sure about. This number we're guessing on that graduated cylinder. So if this is 600, this is 700, my guesses can be 600, 700, or 650. Oops, excuse me, 700 and 800. I don't know why I said that. Ignore that. So 700, 800. So my guesses can be, my measurement's going to be 750 because that's my estimated decimal place. Okay, that one was kind of done for you. This one, this is 600. This is 700. So that each one of these lines is worth tens, which means that one more place value to the right is the ones. Now, the reason that this one has a decimal point after it is to show us whether or not it was estimated or measured. Okay, so it's telling us now, again, we know that this 2 is we're sure about, and the 0 is a guess. And that's why that decimal point is going there. If that 0 wasn't there, it would probably be more the 6 we were sure about and the 2 we were guessing. So, if this is 610, this is 620, these are going up by ones. The difference between these is 10, and we know that we are dividing it by 10 little lines. You can also guess and check and just count 611, 612, 613, 614, 615. So we're going by ones. This is tenths. So this one, depending on how you're reading it, some of you may remember that we're supposed to measure from the bottom line. So we could say that this is 611 and 612. So I'm going to actually change this. Oh no, that doesn't end in a 0.5. I'm going to say that this is 612.0 to show that I guessed that last number. Okay, this is 610, 611. There's a difference of 1 in 10 increments, so that means this is going counting by the tenths place, which means we need to guess to the hundredths place, which is why that ends up at, we know that this is 610.1 and 610.2. So your guesses would go one place further. We could say 10, 15, or 20. They thought it was closer to that line and said that. Oops, I don't want to print this. Go away.